Let's look at this question right now. Okay, the question is, two wires are used to suspend a sign that weighs 500 newtons. The two wires make an angle of 100 degrees between each other. If each wire is exerting an equal amount of force, how much force does each wire exert? So basically this question is telling you that the force of tension is the same, and we are looking for the force of tension, and the angle between the wires should be 100. So basically we're gonna have to split up that angle into 50 and 50, just like what you see on the right on the small board right now. But I'm just gonna go ahead and guide you through the steps. So the first thing you do from reading the question was to just go ahead and start drawing the free body diagram, which is all the forces. So basically I have two wires, and then I have a weight right here. And the force of the gravity is equal to mg. So we know it. And also, the question is telling you that the angle in between is 100, but for our purposes, we want to split this in half so that we would divide the force into two different components, which is the x and the y. Tension 1, tension 2, but since the question is suggesting that the force of tension is the same, so I don't have to like write down a T1 and T2 since it's the same, so I will keep it as T. So the angle is about 50 because the total angle between the two wires is 100. So therefore, obviously, the angle in between is only 50. Then all we know, okay, this is the force. So basically, you have to split up the force into T cosine of 50. You do the same thing on the left tension. 50. T sine 50. This is all one of the things that you need to know. T sine 50. So now double check, do we have all the forces with the right direction and the magnitude? So since the forces are vector, therefore you must have an arrow pointing that will suggest the direction it is. And also, if you have forgotten already, I'm just gonna go ahead and give you guys a refresh on this one. If it is up or right, it's positive. If it is pointing to the left, down is negative. So you need to know positive, positive, negative, negative. Those are direction of the forces. So now we're gonna go ahead and follow Newton's law of motion by applying all the forces only in the x direction first. So sum of the forces is equal to 0 because it is at equilibrium, or it is at static equilibrium, which is not moving at all. So there's no acceleration, or therefore there's no velocity, so it becomes 0. Sometimes the AP questions will ask you to go ahead and derive the equation first. This is how it's done with no number. But if they actually ask you to solve for the problems, then you will go ahead and follow that step first. So that force is pointing to the left, so therefore it's negative 50 plus, since I have two different forces, so I'm adding them up, is equal to 0. So from this step right here, the conclusion would say that T sine 50 is equal to T sine 50. Therefore, T is equal to T. I'm just confirming the statement that the tension is the same. So now we're going to go ahead and take into consideration of the forces in the y direction. It also must be equal to 0. So we're going to go ahead and look at the forces in the y direction, which is vertically or up and down. How many forces do we have and what direction are they? At this point, if you can answer the question, go ahead and tell me in class so that we get extra credit by identifying all the forces. in the y direction. So basically we have t cosine 50. Since I have two of them, I'm actually adding them up. I'm just going to go ahead and add them up just for you to see it. Plus negative mg, because by our convention, forces putting downwards is negative. So since these two forces are the same, so I'm just going to combine them. 50 must equal to the weight. And we are tasked to solve for, let me see, for the tension, not the mg. So the next question I am about to tell you, they will ask you to solve for the mg. You will follow the same step, but instead of looking for t, then you look for mg. But go ahead. So now, since I'm looking for t, I'm going to have to isolate everything. So as you can see that 2 and cosine 50, I actually do multiplication with the t. So in order for me to get rid of that one, I'm just going to go ahead and do this one right here. It will be t cosine 50. I do both sides of the equation. So for this one, get rid of everything. The only thing I have left is the force of tension, which is equal to mg divided by cosine 50. So in the question, it will tell you that the weight is already in 500 Newton. So which is suggesting that mg is equal to 500 divided by cosine 50. Go ahead. At this point, you may want to go ahead and attempt to problem solve by just plugging in the numbers, just like what you see on the last step. It will be 500 divided by cosine 50. And that should give you the answer of 777 Newton. So that's how you solve for this question.